To calculate this intersection between foot and ground, we're going to use a tool found in the Geometry Queries folder of the preset menu. If we pull in a RayCast node, you can see that a RayCast node accepts two main inputs, the geometry and position. We're going to use the position of all of the points on our grid to determine whether or not the body geometry penetrates those positions, and if so, we'll move the positions of those points in the direction of the geometry's penetration. So essentially, if there's any collision between the two objects, move the points on the grid in the direction of the colliding object or the intersecting object. So the foot would be moving down through the grid. You can see that when we input both a surface and a position, we output a location, and the location is not a 3D vector. What we actually need is to convert our location back into a 3D vector, a per point position of each particle, and use that to set the final location of the points. So to begin with, I'll start by taking the grid's point positions and bring them into my graph. Again, we're referring to the grid here. So if I was to use the point position compound plugged into the RayCast input position, I should successfully pass that argument. As far as the geometry goes, I'll bring in the Malcore character, body geometry, and output the surface into the geometry input of the RayCast node. So now we're passing a geometry, our intersecting object, and the object with which we're going to calculate new point positions, the self object. In order to get location back into a 3D vector, we need to get a 3D vector, so a per point 3D location from this RayCast output. To do that, we're going to use a simple node.